Imagine waking up one morning and without any warning, the sky turns a blinding white. In a matter of seconds, all life on Earth begins to wither. There is no explosion, no heat, all there is just a wave of invisible energy sweeping across the planet. This sounds like a story out of science fiction, right? But trust me, this is not a science fiction. So, what could cause such an apocalypse? The answer is one of the most powerful forces in the universe: gamma rays. Hi, I am Eggy, and today I am explaining about the gamma ray and its threat to life on Earth. Gamma ray bursts are intense flashes of gamma radiation originating from deep space from galaxies billions of light years away. If we look at the electromagnetic spectrum, we can see gamma rays are just like visible light, but they have much smaller wavelength, which means they have much higher energy. These gamma rays are produced by some of the most extreme events in the universe, like supernova and collision of neutron stars. Gamma ray bursts are so powerful they can release more energy in few seconds than our sun will emit over its entire 10 billion years lifespan. Talk about sheer power. To put it simply, gamma rays are like intense laser beams which pack enough energy to fry just about anything in their path. Let me tell you an interesting story about the discovery of gamma ray bursts. During the Cold War in 1967, US military launched satellites which were designed to detect gamma radiation produced by the nuclear tests done by the Soviets. They collected and analyzed data from the satellites, and they were successful enough to detect gamma rays. But to their surprise, the gamma rays were originating from deep space. After decades of research, scientists discovered that gamma ray bursts are the universe's brightest event. So, what started as a search for hidden nuclear tests led to one of the most significant astronomical discoveries. How are gamma rays produced? Before I answer that, we need to know there are two types of gamma ray bursts: short duration and long duration. Firstly, let's focus on short duration gamma ray bursts. These bursts last less than 2 seconds, but most of the time, they only last for a fraction of a second. Short gamma ray bursts are believed to be produced from the merger of two dense objects, such as the neutron stars or a neutron star merging with a black hole. You may have heard about black holes, but what are neutron stars? Neutron stars are the remnants of massive stars that have undergone supernova. They are very compact and dense, with a mass comparable to the Sun, compressed into a sphere with a radius of about 10 kilometers. For my American audience, that's 6 miles. When two neutron stars form a binary system, they orbit each other in a tight spiral, gradually losing energy through the emission of gravitational waves. As the neutron stars spiral towards each other, their immense gravitational fields distort space-time and generate intense gravitational waves. As they collide, the neutron stars merge into a single, highly unstable object that quickly collapses into a black hole or a highly magnetized neutron star known as magnetar. This merger triggers the release of a vast amount of energy, and a portion of this energy is emitted as a burst of gamma rays. This emission is highly concentrated into narrow jets that are launched at nearly the speed of light. A short gamma ray burst is more like a lightning strike: quick, intense, and gone before you blink. A long gamma ray burst, on the other hand, is more like a slow-motion explosion from Oppenheimer movie. Still incredibly powerful, but it lasts just long enough to really do some damage. So, when a gamma ray burst lasts over 2 seconds to sometimes several minutes, it is classified as a long-duration gamma ray burst. Yes, 2 seconds is a long time. These long gamma ray bursts are believed to be originated from the collapse of massive stars several times larger than our Sun. Essentially, these cosmic death rays are born from some of the most violent events in the universe. When the life cycle of these stars ends, the fuel in their core gets depleted and collapses under its own weight, reaching high densities and temperatures. In a fraction of a second, the core collapses into a black hole, while the outer layers of the star fall inwards. As the outer layer of star collapses inward, some of the material accretes onto the newly formed black hole, forming an accretion disk. The black hole's intense gravitational pull and rapid spin generates a huge amount of energy. This energy is then transferred to the surrounding material. Magnetic fields in the accretion disk become twisted and amplified, and under the right conditions, they channel energy into narrow jets that are ejected from the poles of the black hole at nearly the speed of light. This energetic jet interacts with stellar material, causing shock waves that accelerate particles to near light speeds. These high-energy particles emit gamma rays. One quick note, if you are enjoying this video so far, please consider hitting that like button and subscribe to the channel for more videos like this. Okay, let's go back to the topic. So, how can something millions of light years away possibly affect us? The answer lies in the sheer power and energy of gamma rays. If Earth were in the path of one of these bursts, even from a distant part of the galaxy, the consequences can be catastrophic. Let's understand how. Now, if you remember earlier, we said gamma ray bursts can release the same amount of energy in seconds that our sun produces in its entire lifetime. If a gamma ray burst were to hit Earth, saying it would be bad would be an understatement. The impact would be devastating. We will consider three main points on how it will be devastating for us. The first immediate effect would be the destruction of the ozone layer. The ozone layer is the protective layer in our upper layer of atmosphere which protects us from the harmful UV rays of the sun. When the gamma rays hits the Earth's atmosphere, they collide with so much energy that it breaks apart the nitrogen and oxygen molecules into highly reactive atoms and ions. These reactive nitrogen ions react with oxygen molecules to produce nitrogen dioxide. Nitrogen dioxide can also react with the nascent oxygen to produce nitrogen oxide. These oxides of nitrogen are known to destroy the ozone layer. The nitrogen oxides react with the ozone molecules, breaking down ozone into molecular oxygen. This process can be sustained over time because nitrogen oxides are not consumed in the reaction, allowing a small amount to destroy a large amount of ozone. With the ozone layer depleted, much more of the UVB radiation would reach the Earth's surface. This increased UV exposure can cause DNA damage in living organisms, leading to higher rate of skin cancer in humans, reduced crop yields, and damage to marine ecosystems, and many other effects. Now coming to the second effect, we kinda talked about it in the first one. We explained how gamma rays help to form nitrogen dioxide gas. Nitrogen dioxide is a brown-colored gas, and when it accumulates in the atmosphere in large quantities, it forms brownish smoke. This smoke can scatter sunlight, which reduces the amount of sunlight that reaches the surface of Earth. This reduction in sunlight could lead to global cooling. The third way is the direct exposure to this highly energetic beam. The dose of radiation from a gamma ray burst could be much higher even from nuclear explosions. Direct exposure to this highly energetic beam can cause immediate and severe radiation damage. Gamma rays have a high penetrating power, meaning they can pass through your skin and cause significant ionization. This ionization can break chemical bonds in DNA, proteins, and other critical cellular components. The most critical damage would be to the DNA. The ionization could cause double-strand breaks in DNA, which are difficult for cells to repair. If enough DNA is damaged, it can lead to cell death, mutations, or cancer. There is a speculation that around 450 million years ago, gamma ray burst may have caused a mass extinction event. This hypothesis suggests that a gamma ray burst might have been responsible for the Ordovician Silurian extinction by depleting the ozone layer and triggering a collapse of around 85% of marine ecosystem. While this is just a speculation, it highlights the potential impact of gamma ray bursts on planetary environments. So yes, gamma rays could destroy life on Earth from far away. No explosions, no warning, just a deadly invisible waves from the depths of space. Okay, so do we have to live in constant fear that one day gamma ray burst will wipe all of us out? Luckily, the answer is no. Gamma ray bursts are rare and chance of one hitting Earth directly is low. Scientists estimate that such an event might only happen once every few hundred million years, but the possibility is low, not zero. Researchers are constantly monitoring the skies for gamma ray bursts and studying their effects to better understand the potential risk. In 2004, NASA launched Swift telescope, which is designed for gamma ray burst detection. It is designed to rapidly locate gamma ray bursts and observe their afterglows across multiple wavelengths. Afterglows are the fading emission that follows the initial burst. This capability has allowed scientists to capture the entire life cycle of gamma ray burst, from the initial burst to the fading afterglow, providing valuable data for studying these events. The Fermi Gamma Ray Space Telescope, which was launched in 2008, complements NASA's Swift telescope by observing gamma ray bursts with a broader energy range and higher sensitivity. Fermi's ability to detect high-energy gamma rays has led to the discovery of some of the most powerful gamma ray bursts ever seen. New upcoming missions, such as the European Space Agency's Athena X-ray Observatory and NASA's James Webb Space Telescope, are expected to provide new insights into gamma ray bursts. These instruments will allow for more detailed observations of gamma ray bursts and their afterglows as they operate at higher resolutions and across a broader range of wavelengths. Such observations will help us better understand the physics of gamma ray bursts and their role in the cosmic landscape. Another question we should ask is there any importance about these deadly rays besides wiping out the lives of entire planet? The answer will be yes. There is importance to these potentially life-threatening cosmic events. Gamma ray bursts are one of the most luminous events of the universe. Remember, it can produce more energy in seconds than our sun can in its entire life. Due to this immense brightness, they can be detected from very distant regions of the universe, which makes them valuable tools for looking at the early cosmos. Some gamma ray bursts originate from such a great distance that their light has traveled for billions of years, offering a glimpse into the conditions that existed when the universe was young. Astronomers can discover more about the origins and developments of galaxies, the distribution of matter, and the early stages of star formation by studying gamma ray bursts and their afterglows. We can also learn more about the creation of heavy elements in the universe by studying gamma ray bursts. Remember how short gamma ray bursts are produced? The same event responsible for producing short gamma rays, the merger of neutron stars, is also responsible for the formation of heavier elements like gold and platinum. Gamma ray bursts are evidence of the extreme and violent processes in the universe. They help us understand the violent death of big stars to the collision of neutron stars. These are highly energetic particles which carry enormous amount of energy and can cause catastrophic damage to Earth if we were ever in their path. While the chances of being hit by one of these gamma ray bursts is low, the potential impact is severe. As our observational capabilities continue to improve, so will our understanding of these powerful events. As our understanding of these cosmic events grows, so does our respect for the perfect balance that keeps life on Earth possible. Thank you for watching. Click here to watch more of my videos.